So today let's discuss questions related to partial derivatives. So the question number 1 says that they have given us an expression for u and we are supposed to show that x into partial derivative of u with respect to x plus y into del u by del y is equals to half u into 10 log eu. So if we'll solve it directly, like by calculating del u by del x and del u by del y, then it will be too complicated. So what we'll do is we'll use Euler's first theorem here and then we'll solve it. So if you see that they have given me u as exponential of sine inverse x plus y divided by under root x minus under root y. So if I take log both sides, so I'll get rid of this exponential thing. So let's do that. So it will be equals to log u equals to sine inverse x plus y upon under root x minus under root y. So this is equals to sine log u equals to x plus y divided by under root x minus under root y. Now we can use Euler's theorems on basically homogeneous function. So the Euler's theorem says that Euler's first theorem says that del u by del x into del u by del z by del x plus y into del z by del y is equals to nu. So this is basically the statement of Euler's theorem. So nz, sorry. So let us assume that z is equals to sine log u, and here n is basically a degree of this homogeneous function. So my z is this sine of log u. So let's calculate del z by del x. So del z by del x will be basically cos log u into 1 by u into del u by del x, and my del z by del y will be basically cos log u into 1 by u into del u by del y. So I got the values of del z by del x and del z by z del y. So I can substitute these values here in this Euler's first theorem statement, and then let's see what we get. So first let's calculate the value of n. So I can write z as x plus y divided by under root x minus under root y. So I can take x common from numerator, so I'll be getting 1 plus y by x, and under root x common from denominator, I'll be getting 1 minus under root y by x. So this is equals to under root x 1 plus y by x divided by 1 minus under root y by x. So the degree of degree is 1 by 2. So let's just substitute for these values in the Euler's first theorem. So we'll be getting x into del z by del x is basically cos log u into 1 by u into del u by del x plus y into del z by del y, that is cos log u into 1 by u into del u by del y equals to n, that is half, into z, that is sine log u. Now if I simplify it, I'll I can take this cos log u into 1 by u common, so I'll get cos log u into 1 by u into x into del u by del x plus y into del u by del y is equals to 1 by 2 sine log u. Now if I simplify it further, I'll be getting x into del u by del x plus y into del u by del y is equals to u by 2 into sine log u divided by cos log u. So this gives me x into del u by del x plus y into del u by del y is equals to u by 2 into 10 log u, and this is what we are supposed to prove in the question, that is del u by del x into x plus y into del u by del y is equals to u by 2 into 10 log u. So this is what we are supposed to prove. So let's move on to next question. So the next question says that they have given us u in terms of x, y and z, and it is equals to z into sine y by x, and further x, y, z are in terms of r and s. So they have given us x in terms of r and s as 3r square plus 3s, 4r minus 2s cube, so these are values of my x, y and z, and we are supposed to find del u by del r and del u by del z. So let's do that. So del u by del r, so we know that u is in my x, y and z variable, so this thing will be basically equals to del u by del x into del x by del r plus del u by del y into del y by del r plus del u by del z into del z by del r. Now let's just calculate these values and see what we get. So del u by del x is basically equals to z into cos y by x into minus y upon x square, and del x by del r is equals to 6r. Likewise del u by del y is equals to z into cos y by x into 1 by x, and del y by del r is equals to 4. Likewise if I calculate del u by del z, I'll be getting sin y by x, and del z by del r is equals to 4r. So now let's just substitute these values and see what we get. Del u by del r, so it is equals to del u by del x into z cos y by x minus y upon x square into 6r plus z by x into cos y by x into 4 plus sin y by x into 4r. So this is basically equals to, if I simplify it, I'll be getting minus 6zy r by x square into cos y by x plus 4z by x into cos y by x plus 4r into sin y by x. So this is what I got del u by del r. Now we are also supposed to calculate del u by del s. So let's do that. Del u by del s will be basically equals to del u by del x into del x by del s. plus del u by del y into del y by del s plus del u by del z into del z by del s. So we have already find out value of del u by del x, del u by del y, del u by del z. We are only supposed to calculate value of del x by del s, that is equals to 3. Del y by del s is equals to 6 minus 6x s square, and del z by del s is equals to minus 6s. So if I simplify it, I'll be getting z into minus y by x square into cos y by x into 3 plus z by x cos y by x into minus 6s square plus sin y by x into minus 6s. So this is what I got as del u by del s. So let's move on to next question. You can simplify it further by so let's do that. It is equals to minus 3y z by x square into cos y by x minus 6z s square by x into cos y by x minus 6s into sin y by x. So this is the value of del u by del s. So let's move on to next question. So the next question says that, like, they have given us values of u and y in terms of x and y, and values of x and y in terms of r and theta. So what we are supposed to do is we are supposed to find del of uv with respect to r theta. So u is basically x square plus y square, v is equals to x square minus y square, x is equals to r cos theta, and y is equals to r sin theta. So if I find values of del uv with respect to del r theta, so I'll be getting del u upon del r, del u upon del theta, and del v upon del r into del v upon del theta. So if I solve it, it will be equals to del u upon del r into del v upon del theta minus del v upon del r into del u upon del theta. So let's just find out value of del u upon del r and the other terms. So del u upon del r is equals to del u upon del x into del x by del r plus del u upon del y into del y by del r. So my u is x square plus y square, so del u by del x is basically 2x, and del x by del r is cos theta, plus del u by del y is 2y, and del y by del r is sin theta. So I basically get 2 into x cos theta plus y sin theta. Now let's calculate value of del u upon del theta. So this will be equals to del u upon del x into del x by del theta plus del u upon del y into del y by del theta. So del u by del x is 2x and del x upon del theta is basically minus r sin theta plus 2y into del y upon del theta, that is r cos theta. So if I simplify it, I can take 2r as common and I'll be getting minus x sin theta plus y cos theta. Now let's calculate value of del v by del r. So del v by del r is equals to del v by del x into del x by del r plus del v by del y into del y by del r. So this is equals to del v by del x is basically 2x and del x by del r is cos theta plus del v by del y is minus 2y and del y by del r is sin theta. So this is equals to 2 times of x cos theta minus y sin theta. Further, del v upon del theta is equals to del v by del x into del x by del theta plus del v by del y into del y by del theta. So this is equals to del v by del x is 2x and del x by del theta is minus r sin theta plus minus 2y into del y by del theta will be basically from here r cos theta. So if I simplify it, I'll be getting, I can take minus 2r as common. So I'm left with x sin theta plus y cos theta. Now if I just substitute these values in 1, so let's see what I get. So my del u comma v with respect to del r comma theta is basically equals to del u by del r into del v by del theta minus del v by del r into del u by del theta. So if I just substitute values, I'll be getting del u by del r as 2 into x cos theta plus y sin theta and del v by del theta is basically this minus 2r into x sin theta plus y cos theta minus del v upon del r, that is this, so it is 2 into x cos theta minus y sin theta into del u by del theta, that is this 2r into minus x sin theta plus y cos theta. So this thing is equals to minus 4r into x cos theta plus y sin theta into x sin theta plus y cos theta minus 4r into x cos theta minus y sin theta into minus x sin theta plus y cos theta. So I can take minus 4r common, minus 4r, and if I take product I'll be getting x square sin theta cos theta plus xy sin square theta plus xy cos square theta plus y square sin theta cos theta plus minus x square sin theta cos theta plus xy sine square theta and plus xy cos square theta and minus y square sine theta cos theta. So this balances out this one and this balances out this one. So if we simplify it, I'll be getting minus 4r into, I can club these two terms by taking xy common, so xy into 1. Likewise, I can club this in this term, again I'll be getting xy into 1. So this is equals to minus 4r into 2xy, that is minus 8r into xy. I can eliminate x and y as by putting value of x and y, that is r cos theta and r sin theta. So I got it as minus 8r cube sin theta cos theta. So this is my final answer. So let's move on to next question. So the next question says that they have given me value of u. U is equals to basically tan inverse x cube plus y cube by x minus y, and here x is not equals to y, so if I calculate tan of u, that will be basically equals to x cube by y cube divided by x minus y, and I can write it as, I can take x cube common from numerator, so I'll be getting 1 plus y by x cube divided by 1 minus y by x. So this is equals to x square into 1 plus y by x cube divided by 1 minus y by x. So you can see that tan u is basically homogeneous and it has degree 2. So we can use Euler's theorem to get this, because if we'll directly calculate it, it will be too complicated. So the Euler's second theorem states that the Euler's first theorem says that x into del z by del x plus y into del z by del y is equals to nz, and Euler's second theorem says that x square into del square z by del x square plus 2xy into del square z by del x del y plus y square into del square z by del y square is equals to n into n minus 1 into z. So let's solve it. Let us take our z as tan of u. So let z is equals to tan of u. So if I calculate del z by del x, I'll be getting sec square u into del u by del x, and del z by del y will be basically equals to sec square u into del u by del y. So let's just put these values in the Euler's first theorem and see what we get. So we'll get x into sec square u into del u by del x plus y into sec square u into del u by del y is equals to n, that is 2, and z, that is tan u. So if I simplify it, I'll be getting x into del u by del x plus y into del u by del y equals to 2 tan u into cos square u. So this is equals to 2 sin u cos u only, because I can just write tan u as sin u upon cos u. So from here I got x into del u by del x plus y into del u by del y is equals to sin 2u. Now let's just calculate double derivatives and see what we get. So if we'll find del square z by del x square, del square z by del x square will be basically equals to del by del x into del z by del x, that is sec square u into del u by del x. So this thing will be equals to sec square u into del square u by del x square plus 2 sec square u into tan u into del u by del x whole square. Likewise, if I calculate del square z by del y square, that will be equals to del of del y of sec square u into del u by del y. So if I calculate it, I will be getting sec square u into del square u by del y square plus 2 sec square u tan u into del u by del y square. Also in Euler's theorem we will be needing del square z by del x del y. So del square z by del x del y will be equals to del by del x into del z by del y. So this thing is equals to del by del x into sec square u into del u by del y. So if I simplify it, I will be getting 2 sec square u tan u into del u by del x into del u by del y. Yeah, that's all I'll get. So let's substitute these values and see where we reach. So if we'll substitute these values in Euler's second theorem, so I'll be getting x square into sec square u into del square u by del x square plus 2 sec square u tan u into del u by del x square plus 2xy into sec square u tan u into del u by del x into del u by del y plus y square into sec square u into del square u by del y square plus 2 sec square u tan u into del u by del y whole square is equals to n, that is 2 into n minus 1 into z, and our z is basically tan of u. So if we simplify it, I will be getting sec square u into x square del square u by del x square plus y square into del square u by del y square. Likewise, I can take common as 2 sec square u tan u, so I'll be left with x square into del u by del x square plus y square into del u by del y square plus 2xy into del u by del x into del u by del y, and this whole thing is equals to 2 tan u. So if I simplify it, I'll be getting sec square u into x square del square u by del x square plus y square into del square u by del y square plus 2 sec square u into tan u. So if I simplify it, you can observe that it is forming whole square of x into del u by del x plus y into del u by del y whole square is equals to 2 tan u, and we have already found out value of this term using Euler's first theorem. So that basically gives us that this thing is equals to sine 2u. So if we simplify it, so we'll be getting sec square u into x square del square u by del x square plus y square into del square u by del y square plus 2 sec square u into tan u into sine 2u whole square is equals to 2 tan u. So if I guess we missed a term somewhere. Yeah, so when we'll take derivative of it with respect to x, so we have taken the derivative of this, we have missed this derivative of this, so we'll be getting sec square u into del square u by del x del y. So here it will be sec square u into del square u by del x del y. So here we'll get another term, that is 2xy into del square u by del x del y. That is 2xy into del square u by del x del y plus 2 sec square u tan u. So if we further simplify it, we'll be getting sec square u into x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y plus 2 into 2 by cos square x into cos square u into sin u cos u into 4 into sin square u into cos square u is equals to 2 tan u. So this cos square balances this. So we are left with x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y plus 4 2s are 8 sin cube u divided by cos u into sec square u is equals to 2 tan u divided by sec square u. We have basically divided the whole term with sec square u. So we are left with x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y plus 8 sin cube u. This sec square will be given basically cos u is equals to 2 sin u by cos u into cos square u. This cos u balances this. So we get basically x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y as 2 sin u minus 8 sin cube u by cos u. So the term on left hand side is same, so if we simplify the term on right hand side, we can take 2 sin u as common, so we'll get 1 minus 4 sin square u by cos u and we're supposed to prove 1 minus 4 sine square u into sine 2u. So if we take cos u as common, so I'll be getting 1 by cos u minus 4 sine square u by cos u. And by cos square u it will become, so this thing is equals to sine 2u into, if I take LCM as cos square u, so I'll be getting cos u minus 4 sine square u. So we are supposed to prove 1 minus 4 sine square u into sine 2u. This is what we are supposed to prove. So let's see with the, I guess we have missed a term somewhere. Yeah, so here it will be sec u. Let's write it again only from here. So here we'll get sec u, because cos u into sec square u it is. So if I simplify it, yeah, so now I can write it as 2 sine u into cos u into 1 by yeah, here also I missed this cos u, so it will be 2 by sec u only. So this term is basically equals to, I can take 2 sine u by sec u common, so I'll be left with 1 minus 4 sine square u. So this thing is equals to 2 sine u cos u, that is sine 2u into 1 minus 4 sine square u. So this is what we are supposed to prove. So it involves a lot of calculation and there is possibility that we miss out on some terms. So you have to be very careful while solving this. So let's move on to next question. So the next question says that there are two parts in the next question. So in the first part, they have given me u, and u is basically in terms of, u is basically function of x, y and z, y minus z, z minus x and x minus y, and we are supposed to find sum of del u by del x plus del u by del y and del u by del z. So let's solve it. So what we can do is basically name them. So let us assume that my alpha is equals to y minus z, beta is equals to z minus x, and my gamma is equals to x minus y. So if I find del u by del x, so it will be basically del u by del alpha into del alpha by del x, because my u is function of these and they are function of x, y, z. So it will be del u by del beta into del beta by del x plus del u by del gamma into del gamma by del x. So this thing is equals to del u by del into del alpha by del x is 0 plus del u by del beta into del beta by del x is basically minus 1 plus del u by del gamma into del gamma by del x is 1. So this is equals to basically del u by del gamma minus del u by del beta. Likewise we can find del u by del y. So this will be basically equals to del u by del alpha into del alpha by del y plus del u by del beta into del beta by del y plus del u by del gamma into del gamma by del y. So this will be equals to del u by del alpha into what is del alpha by del y, that is 1, plus del u by del beta into del beta by del y is basically 0 plus del u by del gamma into del gamma by del y is minus 1. So this is equals to del u by del alpha minus del u by del gamma. Likewise del u by del z will be basically del u by del alpha into del alpha by del z plus del u by del beta into del beta by del z plus del u by del gamma into del gamma by del z. So this thing is equals to del u by del alpha into del alpha by del z is basically minus 1 plus del u by del beta, and del beta into del z is 1 only, plus del z by del gamma is 0. So this term doesn't contribute, so we are further supposed to find some of these. So it will be del u by del x plus del u by del y plus del u by del z will be equals to del u by del gamma minus del u by del beta plus del u by del alpha minus del u by del gamma minus del u by del alpha plus del u by del beta. So this term balances out this one. Likewise this balances out this one, and this one balances out this one. So the sum is basically equals to 0. So let's move on to next question. So the next part, there are two parts in this question. So they have given us u, that is basically function of x, y and z, and we're supposed to find del u by del x plus del u by del y and so on. So in the second part, u is function of x, y and z, and it is equals to x by y plus z plus y by z plus x plus z by x plus y, and we supposed to find value of x into del u by del x plus y into del u by del y plus z into del u by del z. So for that we need to first find out values of del u by del x, del u by del y and del u by del z. So if we solve it for del u by del x, so I'll be getting 1 upon y plus z minus y divided by x plus z square minus z divided by x plus y square. Likewise if I find del u by del y is equals to it will be minus x divided by y plus z square plus 1 divided by z plus x minus z divided by x plus y square. Likewise, we can find value of del u by del z. So that will be basically minus x y plus z square minus y divided by x plus z square and plus 1 divided by x plus y. So values of x into del u by del x plus y into del u by del y plus z into del u by del z will be basically equals to x times 1 by y plus z minus y divided by x plus z square minus z divided by x plus y square plus y times 1 by z plus x minus x divided by y plus z square minus z divided by x plus y square plus z into 1 by x plus y minus x divided by y plus z square minus y divided by z plus x square. So it will be x by y plus z. I'm taking this and this thing common, plus y upon z plus x plus z upon x plus y. So other terms will be basically minus xy divided by x plus z square, and other terms with x plus z square denominator are x plus z, this. So it will be minus xy minus yz divided by x plus z square. Likewise, we can club other terms. So minus xz divided by x plus y square, and this term, that is minus yz divided by x plus y square, plus this we are left with. So it will be minus xy divided by y plus z square minus xz divided by y plus z square. So if we simplify it, we'll be getting, so if you observe that this term is equals to u only, so it will be u plus, from here we can take minus y as common, minus y into x plus z divided by x plus z square, plus from here we can take minus z as common, so we'll be left with x plus y divided by x plus y square, plus from here we can take minus x as common, so we'll get y plus z divided by y plus z square. So this thing is equals to u minus y divided by x plus z minus z divided by x plus y and minus x divided by y plus z. So this thing is equals to u minus, so if we take minus common, so the inside term will be left with is u only, so this is equals to 0. So let's move on to next question. So the next question says that, so they have given us that u is a term in sine inverse and some x and y. U is term in basically x and y, and then we are supposed to show that sine square u is a basically homogeneous function of x and y, and degree of it is basically minus 1 by 6. And further we are supposed to prove a result. So let's see that. So u is basically given to as sine inverse x raised 1 by 3 plus y raised 1 by 3 divided by x raised 1 by 2 y raised 1 by 2. So from here sine of u will be basically, it is under root also, here it is under root also, So sine of u will be basically under root x raised 1 by 3 plus y raised 1 by 3 divided by x raised 1 by 2 plus y raised 1 by 2. So from here I'll get sine square u as x raised 1 by 3 plus y raised 1 by 3 divided by x raised 1 by 2 plus y raised 1 by 2. So I can write sine square u as, I can take x raised 1 by 3 common from the numerator, so I'll get 1 plus y by x divided by 1 by 3 divided by x raised 1 by 2, 1 plus y by x raised 1 by 2. So it will be equals to x raised 1 by 3 minus 1 by 2 into 1 plus y by x raised 1 by 3 plus 1 plus y by x raised 1 by 2. So this thing is equal to x raised minus 1 by 6, 1 plus y by x raised 1 by 3 divided by 1 plus y by x raised 1 by 2. So you can easily see that this thing is equals to x raised n into function of y by x. So from here we can say that sine square u is basically a homogeneous function and its degree is basically x raised minus 1 by 6. So we have shown that sine square u is a homogeneous function with degree minus 1 by 6. Now we are supposed to show that. So it is a homogeneous function, so we can easily use Euler's theorem on this question. So we'll be using Euler's first theorem. So first let us assume z as sine square u. So Euler's theorem states that x into del z by del x plus y into del z by del y is equals to nz, and our n is minus 1 by 6 into z. So from here I'll get x into del z by del x will be basically 2 sine u cos u into del u by del x plus y into 2 sine u cos u into del u by del y equals to minus 1 by 6 into z, that is sine square u. So if I simplify it, I'll be getting x into del u by del x plus y into del u by del y is equals to minus 1 by 6 into sine square u divided by 2 sine u cos u. So this balances this one. So it will be equals to minus 1 by 12 into tan u. Likewise, if we use Euler's second theorem, that states that x square into del square z by del x square plus y square into del square z by del y square plus 2xy into del square z by del x del y is equals to n into n minus 1 into z. So let's just substitute values. So it will be basically equals to x square into del by del x into del z by del x, and del z by del x is basically this term, that is sine 2u into del u by del x plus y square into del by del y into sine 2u into del u by del y plus 2xy into del y del x will be basically del y del x into del z by del y, and del z by del y is this, that is sine 2u into del u by del y is equals to n, that is minus 1 by 6 into minus 1 by 6 minus 1 into z, and our z is basically sine square u. So from here I'll be getting x square into sine 2u, that will be basically 2 cos 2u into del u by del x. So that will be del u by del x square plus sine 2u into del square u by del x square plus y square into 2 cos 2u into del u by del y whole square plus sine 2u into del square u by del y square plus 2xy into 2 cos 2u into del u by del x into del u by del y plus sine 2u into del square u by del x del y is equals to 1 by 6 into 7 by 6, that is 7 by 36. 7 by 36 into sine square u. So let's just simplify it further. So we'll be getting, so we can club in these terms, this, this and this. So what we'll get, so we can take 2 cos u as common. So 2 cos 2u as common, so I'll get x square into del u by del x whole square plus y square into del u by del y whole square plus 2xy into del u by del x into del u by del y plus, and from other terms if I take sine 2u common, sine 2u as common, so I'll get x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y is equals to 7 by 36 into sine square u. So we'll get 2 into cos 2u. So this term is basically whole square of x del u by del x plus y del u by del y plus sine 2u into x square del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y is equals to 7 by 36 into sine square u. So we are supposed to find like on the left hand side we have this term, so let's just take other terms to the right hand side. So we'll get sine 2u into x square into del square u by del x square plus y square into del square u by del x del y. So this thing is equals to 7 by 36 into sine square u minus 2 cos 2u into u. We can replace this using this, that is this thing is equals to minus 1 by 12 tan u minus 1 by 12 tan u whole square. So from here I'll be getting x square del square u by del x square so I can take this sine 2u in the denominator. So I'll get sine 2u into 7 by 36 into sine square u minus 2 cos 2u into tan square u divided by 12 square, that is 144. So if we, the term on left hand side is same, so if we simplify it we'll get sine 2u into, we can take 144 outside, so it will be sine 2u into 144, So we'll get 4 into 7 sine square u minus 2 cos 2u into tan square u. So this thing is equals to 1 upon 144 sine 2u into sine square u minus 2 into cos 2u is basically 1 minus sine square u into tan square u. So I got this because we know that 1 minus cos 2u is 2 sine square u. So from here if I find out value of cos 2u, so that will be basically 1 minus 2 sine square u. It will be 1 minus 2 sine square u. So we simplify it. I'll be getting 144 into sine 2u into 28 sine square u minus 2 tan square u plus 4 sine square u. So this thing is equals to 1 by 144 into sine 2u, 28 plus 4, that is 32 sine square u minus 2 tan square u. And what we're supposed to prove on right hand side is 10u divided by 12. We claim that this thing will be equals to 10u divided by 12, 13 by 12 plus 10 square u by 12. Okay, so let's see how we can get it. Let's just resolve it from here and see what we get. So we have this as equals to, here is sine 2u as well. So this thing is equals to 7 by 36 sine square u minus 2 cos 2u into 1 by 144 tan square u. So if we take sine 2u on other side, we'll get x square into del square u by del x square plus y square into del square u by del y square plus 2xy into del square u by del x del y. So this thing will be equals to 1 by sine 2u into 7 by 36 u square, 7 by 36 sine square u, minus 2 by 144 cos 2u. I can write cos 2u as cos square u minus sine square u into, we have tan square u. So this will be equals to 1 by sine 2u into 7 by 36 sine square u minus 2 by 144 cos square u into tan square u will give me sine square u minus sine square u into tan square u. So this thing will be basically equals to, now I can take the sine 2u inside, so I'll get 7 by 72 into sine square u divided by sine u cos u minus 1 by 144 into sine square u minus, I can take sine square u common, so it will be sine square u into 1 minus tan square u divided by sine u cos u. So this thing will be basically equals to, sin u balances this one, so we'll get 7 by 72 into tan u minus tan u by 144 into 1 minus tan square u. So we need tan u by 12, so what we can do is we can take tan u by 12 common, so we'll be left with 7 by 6 minus 1 by 12 into 1 minus tan square u. So this thing will be equals to tan u by 12 into 7 by 6 minus 1 by 12 plus tan square u by 12, and this is equals to tan u by 12, so this is 14 by 12. So 14 by 12 minus 1 by 12 is 13 by 12 plus tan square u by 12, and this is what we are supposed to prove. So that's all for this video. There are more questions, but video will become too long for that, so we'll discuss them in the next part. So thank you for watching.